All right, good afternoon everybody. My name's Lauren Steenstra and I'm the Geology Manager at Advanced Mining Production Systems, so we're one of the co-sponsors, as Beck mentioned, for the day today. I'm going to be giving Beck a bit of a rest and chairing the afternoon session, so I'd like to introduce Costa. So Costa is the Senior Exploration Geologist for Mincor Resources based in Kambalda. He completed his studies in New Zealand and has 11 years experience in the mining and exploration industry. He's been involved in greenfields and brownfields exploration, resource definition in both surface and underground environments, and has advanced resource development projects in a wide variety of geological settings across the globe. He has worked on 10 different projects in Australia, Zambia, Turkey, Finland, Spain, and exploring for copper, gold, nickel, lead, zinc, manganese, and lithium. Having worked with people from diverse cultural backgrounds, Costa holds great value in building strong relationships with his colleagues, stakeholders, local communities, and Indigenous peoples in project environments. This has allowed him and his team to successfully implement exploration activities in challenging environments. He believes that the ingredients for exploration success is a fine balance of continually challenging the geological and deposit model through rigorous science, experimentalism, and a stroke of serendipity. Please put your hands together and welcome Costa.
Great. So put this down here. Okay. All right, got that organised. Good afternoon, everyone. I'm here today to present to you an exciting discovery called Cassini, which is a komatiite-hosted nickel sulfide deposit that has been recently unearthed. It's taken about 20 years to find a new greenfields discovery in the area, and we're very excited about it. I'm going to present it to you today. Okay, the all-important location, as it is for every deposit, it's all about location. So the ground that Mincor holds, which is presented on this map up here, is in one of the top 3 high-grade nickel sulfide districts in the world. Mincor has a dominant land position, about 300 square kilometres, and within that package, we have about 127 kilometres of basal contact to test. So in the Kambalda district alone, which is essentially, that's Kambalda Dome up there, and that's the Widgiemooltha Dome where most of the deposits are found, has delivered 51 million tonnes at 3.1% nickel for approximately 1.6 million tonnes of contained nickel. Mincor's mineral resource base currently stands at 4.7 million tonnes at 3.7% nickel for approximately 175 kilotonnes of contained nickel. So over the last 20 years, there's really hasn't been a great deal of true greenfields exploration. It's really been focused around the brownfields extensions around the domes. So Mincor really dominates the majority of the prospective nickel terrain in the area around existing mines, proposed new mines, and brownfields extensions and greenfields target. So all the low-hanging fruit was really unearthed, and all the gossans were found through the 70s and the 80s, and there really hasn't been much found since in the last 20 years. So Cassini is really an exciting new discovery for Mincor, and is pretty much undercover and lithologically blind to the surface. So this is the stratigraphic column of a district. This is where nickel sulfide deposits are found on what's called the basal contact. Almost all significant deposits are found on or very near to the basal contact. There is hanging wall mineralisation, but they generally are not that economic. So I'm going to talk through the genetic model of the Kambalda style nickel sulfide deposits. This image here is a lava flow channel in a modern day setting in Hawaii, but it's very akin to what these channels would have been like in terms of its morphology. These types of volcanoes would have been, the lava would have been flowing like sort of treacle or honey, but komatiites have a very high viscosity or low viscosity. They would have flowed more like olive oil at the time, and they were very hot at 1600 degrees. So on the basal contact in this area, there's ubiquitous sediments, which represents a period of quiescence. And so what happens when these komatiites flow over the sediments, they thermomechanically erode the surface, and just bring on this one here. So this shows how, it's a model of how these lava channels thermomechanically erode into the basal contact and assimilate the sulfitic sediments, which is really important because it's the sulfur source for sulfide precipitation. And so you can see down the bottom there, this is a typical ore profile of how you get the massive sulfide at the base, which also invades the footwall. Oops, sorry, backwards. And you get the matrix supported on top and disseminated sulfide cloud on top there. So the way that these sulfides deposit, the sulfur from the sediments is assimilated into the silicate melt, and the nickel partitions out of the olivines as well as the copper and the cobalt, and then they form the nickel sulfides, and they pretty much deposit like sediments in a river channel. So this is what an ore profile looks like at Cassini and core. So you can see there's the basal contact here. So all of the rocks in the region have undergone upper green schist to amphibolite metamorphic events. So there's not really much in the way of olivine cumulates anymore. Pretty much what we see is talc, magnesite, and tremolite minerals. And so this is the zone, the high flux zone above the ore system, which typically has MgO values above 32%. And this represents the disseminated cloud of that high flux zone. So moving down into the profile, we've got weak matrix sulfide supported sulfides, which interstitial talc, tremolite, and magnesite with nickel values of around 1 to 2% nickel. Moving down, we're getting strengthening of the matrix supported, and there's about 70% sulfides with interstitial tremolite, chlorite, and this is where you get grades of about 4 to 8% nickel. And in this particular hole, just had a small amount of massive, but in that massive largely consists of pentlandite, pyrite, and pyrrhotite, and you can get grades between 5 to 20%. And this intersection is 5.5 meters at 6.7% with a true width of about 4 meters. So understanding the fertility of the basal contact is key. Most of the economic deposits, as I said, are found on or near the basal contact. So assessing particular fertility indicators are really fundamental to understanding the channelized flow that could potentially host the sulfides. So not all channels host massive sulfides, but understanding particular elemental vectors are really, really fundamental. So things like high nickel, high MgO, low chrome, and zinc represent the peridotite, which is the area of high flux that we want to vector towards. The flanking positions of these systems are pyroxenites, and they typically have low nickel, low MgO, and high chrome and zinc. So this diagram also shows you can get hanging wall sulfides, but it's very challenging to mine them because they're generally in ultramafic, which is very soft. So another important aspect in trying to find these deposits is defining the basal contact. So the basal contact was flat at one stage. Now, after 4 different deformation events, it's undergone a lot of deformation, and so trying to unravel that to understand the channel morphology and its plunge is really critical. So both these aspects, there's what Mincor uses to allow us for effective targeting and predictive targeting. So what is the search space? Understanding the stratigraphy is really, really key. So we need to find the right basal contact. There's a contact above the komatiite with the overlying DCB, so that's not mineralized. So we do this via mapping and drilling. Obviously, there's not a lot of, as most of you know, there's not a lot of outcrop around the goldfields in general, so it's very challenging to find that basal contact. So we use a lot of different methods, such as geological mapping, geophysics, in particular magnetics, because that gives us the magnetic response of the komatiites, which do host a lot of magnetite. As you can see, the image over here, this is the Widgie Dome, and the red stars represent all the mines, and Cassini, which we're hoping will be a mine. They're all situated around the Widgie Dome, and prospects as well are all on the same sort of trend, channelized trend around it. So magnetic highs, as I said, can be indicative of channelized fertile flows. So looking for complexity in those magnetic highs is really important. So we're looking for really small subtleties which could represent an embayment or a trough structure where these massive sulfides could have accumulated. So collecting data on appropriate drilling grid to intersect a mineralized channel is really important. Some of these channels are only up to 50 meters wide. Some of them have strike lengths of kilometers. So they are quite small, but it's really important for us to understand and integrate the data to understand the fertility and the geochemical vectoring around these channels. So we also use other geophysical methods, pretty obvious ones like moving loop EM and also downhole EM, because these ore bodies are superconductors, so they do provide a good response. But Cassini, being where it's situated, is lithologically blind to surface, so I'll show you what its geophysical anomaly looks like in the coming slide. So firstly, we'll go through the discovery history of Cassini and its early development stage. So back in the early 2000s, there was a magnetic high that was identified near the basal contact through soil sampling and air core drilling. Anglo Gold had a go of the area, and they were looking for gold. And they were doing a lot of air core drilling around the area and discovered they had anomalous nickel when they reassayed some pulps. Jupiter Mines, through 2007 to 2012, they conducted soils and EM surveys over the area and followed up a number of targets with RC and intersected hanging wall mineralization. So in 2012, Mincor acquired the ground after a lot of the previous explorers believed that the ore was, the mineralization was related to sediments and was hanging wall mineralization and was subeconomic. So when Mincor acquired the ground, they did a lot of data integration, looking at the magnetic data, looking at the geochemistry, looking for geochemical vectoring. So in recent developments, Mincor, back between the years of 2012 to 2015, identified economic massive sulfides on contact and multiple channels. Unfortunately, in 2015 and 2018, there was a hiatus in drilling due to low nickel prices. Some high-res mag was completed over the area to help define basal contact. At that stage, it had an inventory of 10,800 nickel tons. And last year, we really ramped up. Nickel prices starting to go up. We drilled 26 drill holes for 10,000 meters. We released our maiden resource for 550 kilotons at 3.4%. For 18,700 nickel tons. And so that's almost a 50% increase there. And this year we've drilled 37 drill holes, 15,000 meters, and we've increased our resource again by 50%, which has been excellent, to almost 1,000 kilotons at 3.8% nickel for almost 38,000 tons. So our next resource update is imminent, and we're hoping to have it released in November. Early November, that is. So this is the magnetic anomaly over the Cassini area. So that white line's the basal contact, and it's essentially defining the nose of a south-plunging fold, or an anticline. So where is Cassini in this area? Does anyone know? Well, it's not there because that's a drill rig. And remember before I said it's really important to look for subtleties in the basal contact that could represent embayment structures. So that's where Cassini is, right there. So I'll just go back again. You can see what it may, oops, why is the button not working? Pointers, there it is. So you can see these embayment structures here that indicate the strike of the Cassini ore body. So Cassini is very much open to the south at the moment, and that's been a big focus for us. But there is this anomaly here to the north-west, which we're very much interested in. We're actually going to be drilling that very shortly. It's our next hole. And we're hoping that this may represent a fertile ultramafic and or a parallel trend of mineralization. So there's been ore bodies in the past, such as Wanaway. There has been a paired trend. There was two channels essentially next to each other that are both mineralized. So we would like to think that might represent a paired channel system, but the drilling will tell us in the coming weeks. So this is an oblique view angle of the Cassini deposit. The grey-green colour is the basal contact, and the red is the ore shapes. And what it's showing is that the Cassini ore body is plunging about 40 degrees to the south-southeast. And these pink holes, these pink spots here are our last good intersections. Here we had 6.3 metres at 7%, and here we had 15 metres at 4.5%, including 8.5 at 7. And one of our most recent holes here, we had a really, really good hit of 12 metres at 5, which includes 9.7 at 6. So we are planning on stepping out and drilling another fence down there, but at this stage we're actually going to be heading back to this area here and testing out this brownfields target here. So there's a potential that you might get another mineralised trend through here. This is a picture of a glorious massive sulphide and our best exploration hole that we've had to date on the CS4 channel. So there's actually 9 different surfaces, or 8 to 9 different surfaces. We believe that this system may be comprised of 2 separate channels, and it's been offset by some structural offsetting, which has caused actual surfaces, and that's how we model the ore bodies. So that's our best intersection there today, at 7.17 metres at 11.5%. This is a cross-section at the northern end of Cassini, just to give you an idea of the structural deformation of the channel itself. So that's the cover sequence there. It's quite thin at the northern end, about 40 metres, and as you come south it gets up to about 100 metres. So it's tertiary in age. There's basically no evidence of nickel mineralisation in the cover, so it's a very challenging ore deposit to drill. So we've got our ways in getting through it, through failure of course. So as you can see in here, the red represents the nickel sulphide, massive sulphide, and also matrix sulphide. You can see how there's a leading edge of basalt here, which has been structurally offset and folded up here. And there's the ores coming off contact, which is possibly due to attenuation of these sulphides during compressional folding events. There's also a lot of sediment related to the Cassini ore body, which is a little bit unusual because sediment typically indicates the flank of their system, so the colder parts of the system that you generally don't see really high-grade nickel sulphides, but Cassini is quite different. It has areas where we have high-grade nickel, thick massive sulphide, but we also have sediment related to it as well. So that's an unusual characteristic about Cassini. So moving south again, you can see this is not working. Really? The pointer is not working. Oh, there it is. It's back on again. The battery must be no good. So so this is the anticline, and the ore body is sitting on the western flank of this antiform here. It's also been offset. You can see these porphyries here have come through and invaded the contact. They essentially represent some faults there that the porphyries have invaded. But we've got some really good intersections on this one here. So we've got 6.4 metres at 7.2%. This is the massive sulphide here. Down here, above it here, we've got sediments. So it's sediment related. Sorry, below it is the sediment. We've got massive sulphide on top of it. And this intersection was very, very, very high grade with a good true thickness of 4.5%. Moving south again, another 120 metres. You can see the ore system is on this side is starting to flatten out again. That leading edge is starting to drop away. You're getting these steps up here where the ore is sitting on. Porphyries are still there. They're pretty much pervasive through the whole entire system as we come down plunge. There's a really nice hole here, 6.4 at 7.23% with a true width of 7.5 metres. Sorry, 4.5 metres. And this is the section that's got our best intersection on it here of 7.2 metres, 11.5%. That is a tray of massive pyrite, petalendite, massive sulphides, and we'd like to see that every day of the week. But now I've really zoomed out in this image here, and you can get a good idea. There's the disseminated carapace or halo around the system here. These are the CS1 to CS9, which is not up here, but these are the surfaces of ore here. And right now we've been focusing a lot of our attention on the CS5, which has been very productive as we've been following it down plunge. So you see, there's still a lot of opportunity around Cassini. We have drilled on the eastern Symform here. It hasn't been productive in terms of massive sulphide, but there's been a lot of smoke in that area, which could indicate down plunge that we may get a remake of a channel down there with massive sulphide. So we're going to continue to focus on that, but not largely. Most of the mineralisation is sitting here on this western flank. But there's a lot of opportunities down plunge as well, which we possibly won't get to with surface exploration because we're getting quite deep. So it's going to be some underground drilling that will have to assess those areas. Thank you. So what are the characteristics of Cassini? So the system is perched on the western limb of a south plunging fault. It's composed of at least 2 channels that have been offset by thrust faulting, as you can see there. There's a major thrust fault here which has brought up that basalt contact there. You can see thrust faulting through here, which is offset and created these little steps, and these steps are real. We've understood that through drilling. It's composed of at least different ore surfaces, and the primary ore is made up of pyrrhotite, pentlandite, pyrite with minor chalcopyrite, magnetite, and the odd bit of chromite. So the pyrite to pentlandite ratio is about 2 to 3, and the massive ore grades can range from about 6 to 18%. So there's a lot of variation of sulfide tenor along these surfaces. There's a lot of variability in thickness, and the ore can be quite poddy as well. So we're following channels, surfaces down plunge, and all of a sudden they just stop, and then they can remake again. So they are quite challenging. You do have to be a bit persistent. So MGO, I've got here, which is the high flux zone around the ore system here. This goes up to about 45%, but largely it's about a 32% cutoff there, and that defines the high flux zone of the channels themselves. So, as I discussed before, there's a lot of potential left in a brownfield setting. So this is a bubble plot that compares Cassini to all other deposits in the area. What it's showing is nickel grade on the x-axis, so on the y-axis, and contained tons on the x. So you can see here, Cassini is still quite small compared to the big granddaddy over here, Ottajuan, in the North Cambalda region. The Cambalda Dome, but at the moment it's sitting quite high in grade, and it's only sitting at 40,000 tonnes. So essentially all the other ones here are from the orange bubbles are from the Cambalda Dome, the blue are from the Wedgie Dome, which is where Cassini is, the yellow are the tramways belt, and all the others are outside of these areas. But we have a firm belief that our current drilling is only going to make that bubble move that way. So, Cassini has its own jewellery box as well. We had an exceptional, spectacular hit of gold, very high-grade visible gold in one of our holes in our most southern section that we haven't followed up yet. It was 1.45 metres at 1,000 grams, high up in the hanging wall, about 200 metres from the basal contact. It was hosted in a quartz vein that didn't appear to have much structural deformation or sharing at all, so it's very isolated. We sort of truly understand it. It has a sort of southeasterly dip on the structural measurements that we've taken, but it had an incredible interval of 0.2 at 7,610 grams per tonne. So it's very curious, and we're keeping an eye on it. Sorry, what was that? Oh, 1 minute to go. I'm getting there. Okay, so Mincor has a very aggressive exploration strategy. So the Cassini resource definition, we're going to keep continuing down plunge to extend the resource. We're going to update the Cassini resource with the recent down plunge sections. We're planning on the maiden ore reserve, which is pending, the imminent resource update, and there's potential early capital works at Cassini and potentially 2020. So we're going to continue with brownfields exploration, especially around the Cassini North Mag High target. We're going to investigate the CS1 channel as well. And we've also got ongoing greenfields work, which is currently being drilled at the moment down here along south of the Cassini contact at a prospect called Juno 4, which we're doing RC drilling. We've also got some air core drilling lined up at another prospect as well. And here are some of the brains behind the discovery and the exploration strategy. There's Rob Hartley there and Mark Muller, the principal geologist. So we're going to move to the Cambalda Dome region to look at what else Mincor is doing. Mincor has recently acquired the Long operation in August 2019. So Long is largely mined out, and it is a pretty significant deposit in the area. So this green surface is the basal contact. This is the Cambalda Dome here. We have approximately 18,000 nickel tonnes in reserve at Durkin North, and what the plan is, we're currently drilling underground here at the Spanner resource, the proposed development for the area is that we're going to do a development drive from the spanner to link up with Durkin North, which will create an exceptional drilling platform for exploration in the area. Because this area here, before the purchase of Long, there was a big tenement boundary here and no one did any exploration around there, largely. It was very, very limited. So there's a theory that these systems are actually wrapping around the dome and connecting. So there's a lot of exploration potential in this area. And there is a target here called the US Knob. I'm sure a few of you that came to mind was a prominent political figure, but no, it actually means the ultra-sized nickel ore body channel. So this was intersected back in the late 90s by WMC. They found some off-contact mineralization there. It was followed up by Mincor, but they couldn't get to the contact. In 2013, BHP Nickel West did a north-south 3D seismic line through there, and it was understood that it picked up this channel and it probably has an east-west orientation. So the theory of this channel still really holds sound, and it will definitely be chased up once we get this development drive in. There's just so much potential in this area that's untested. It's very exciting. So Mincor's strategy, what is our strategy? We're focusing on re-establishing sustainable high-quality, high-grade nickel production in a world-class Campbell district. So Mincor has signed an offtake agreement with BHP Nickel West in 2009, so we can secure a place to send our concentrate, or our ore to make concentrate. We're going to release the maiden reserve statement for Cassini, which is imminent following the resource update in early November. So Mincor is pursuing an integrated mine restart plan, which includes capital development at Durkin North, Long, and Cassini. And we have an aggressive exploration program that, as you can see, continues to deliver results. And we've got a big focus on greenfields and regional exploration next year. And that is all. Thank you for listening. Sure.
So we've got time for one question. If anyone has a question for Costa?
No?
Kind of slightly.
Very good. Thank you.